If a tree falls down in the forest and no one is there to hear it, does it make a sound? How do you know? Taking it one step further, if you hear the tree hit the ground but don't see it, why do you trust your sense of hearing? This might seem like a ridiculous question, but the truth is that despite our total reliance on them, our senses deceive us all the time. You hear this audio and some of us hear yanny while the others hear laurel. You think you hear your friend laughing in the other room, only to come out and see it's just the TV. A stick that looks bent in the water turns out to be straight when you pull it out. You spend what seems like hours walking through a dark and creepy forest, but then wake up and realize you were just dreaming.
But last night, I had dreams, and no one really knows why or for what reason.
The world is a strange place, and for all the knowledge we've managed to gather as a species, there's still a lot more that we don't. Here is everything we don't know, too. I think, therefore I am. You've likely heard this phrase before. Coined by 17th century French philosopher René Descartes, the simple declaration serves as the foundation of all modern philosophy. It's a statement of knowledge, an assertion that if I know nothing else, I at least know I exist. While this may not seem like a revolutionary idea at first glance, it's actually quite significant. Philosophers since the time of Socrates have wondered whether or not it's possible to know anything, because it always seems that the more questions we ask, the fewer answers we're left with. Descartes himself was renowned for his astonishing ability to doubt everything, no matter how trivial, no matter how seemingly obvious. He treated all of his ideas with a radical level of skepticism, believing that doing so would eventually lead him to the truth. This skepticism led him to ask a question that science still hasn't been able to answer. How do I know I'm not dreaming right now?
Well, we're in a kind of dream state here, where time and objects and space seem to be real from our localized points of view. But when we wake up, when we go from the dream state to the waking state, and from the waking state up one level to consciousness, it's like waking up from a dream. There are no objects here.
Or, even more frightening, how do I know that my mind isn't being deliberately misled by some evil genius? Think of it like the movie The Matrix. It's possible that, at this very moment, you're hooked up to a giant machine that is feeding you all the sensory data you're currently experiencing. You aren't really watching this video, it's just the machine making you think that you are. While unlikely, technically it is possible, and there's no way we can disprove it. This is why some people argue that we live in a simulation. Do we or don't we? We just don't know. Descartes argues that our inability to rule out this scenario forces us to doubt everything we think we know, a state of radical skepticism in which we can't trust anything we experience or think. Fortunately, Descartes offers us a way out. Even if we are forced to doubt everything, the one thing we cannot doubt is the fact that we're doubting. If we can doubt, then we can think, and if we can think, then there must be a mind doing the thinking. So while we may never know whether or not the world around us is an illusion, or if we even have physical bodies, we can rest easy in the knowledge that we have minds, that we exist, right? Well, not so much. Later philosophers from Kierkegaard to Heidegger criticized Descartes' claim, arguing that the existence of thoughts does not necessarily imply the existence of a thinker. Friedrich Nietzsche even went so far as to say that the idea that there is something called thinking is itself an assumption. All we can really say then is that something is happening. What that thing is, we just don't know. If you're rolling your eyes at this point, it's understandable. To most people, this all sounds like a bunch of over-intellectualized nonsense with no bearing on the actual world. Even if we do live in the Matrix, I still know that 2 + 2 = 4, that the sun is going to rise tomorrow, and that the earth beneath my feet is solid. Well, hold up on the last point. Part of the reason why it's so difficult to say whether we truly know anything is because we live in a dynamic universe where nothing is ever stable. Everything in existence is always moving and always changing, including the earth itself. Even as you watch this video, the very face of the planet is evolving. Plate tectonic theory is a relative newcomer to science. First pioneered in the 1960s, our understanding of how the Earth shifts and moves is still fairly limited. We've discovered certain things, like the fact that the Earth's rocky crust is in the form of plates that sit on top of a mantle of liquid magma. As this magma circulates and churns, it pushes the plates around, knocking them into each other and creating earthquakes, volcanoes, and mountains. What this means is that, contrary to what we think, the ground beneath our feet isn't solid. It's constantly changing, and if it is, how can we say we know it? Tomorrow, an earthquake could reshape our continents, and so the best we can ever have is a rough approximation of what we think it used to be, not what it actually is. Maybe I'm just trying to strong-arm a metaphor here, but it seems like whenever we investigate what we think we know, our ideas start to crumble. It's an interesting quirk of reality, really. The simpler a question is, the harder it can be to answer. It's for this reason that many people fear death, because we simply don't know anything about what happens after it. Yet I cannot help but think that the fear that we don't know anything about death presupposes that we know what life is, because in reality, we don't know either. While it's easy for us to tell the difference between living and non-living materials, say like an apple versus a rock, but when we try to pin down a precise definition of life, things get complicated.
Cells are the smallest living units of an organism. All cells have three things in common, no matter what type of cell they are. All cells have a cell membrane, which separates the inside of the cell from its environment, cytoplasm, which is a jelly-like fluid, and DNA, which is the cell's genetic material.
All life forms, whether a plant or animal, bacteria or fungus, are composed of cells and are able to meet certain basic fundamental conditions. These include responsiveness, metabolism, energy transformation, growth, and reproduction. For instance, when you smell food, you respond by feeling hungry. Eating a sandwich then starts your metabolic process, which allows you to convert calories into energy. This energy is then used to do things like grow muscles or attract a mate. But this is what life does, not what life is. The main problem is that the primary feature of life is that it's always changing, and definitions by their nature are meant to be static. Perhaps if we knew where life came from, we'd have a better sense of what exactly it is. Unfortunately, we don't know this either. Of course, one day science will figure this stuff out. The secrets to life, the earth, and everything else will be unlocked. All it takes is more advanced technology, more sophisticated methods, and we'll be able to know the answers for certain, won't we? Here's the thing though, science isn't ever 100% certain. When researchers at the European Organization for Nuclear Research, otherwise known as CERN, announced the discovery of the Higgs boson in 2012, they did so by stating that their observations had passed the crucial threshold of 5 sigma certainty. To most people, this term is nothing more than academic jargon, but sigma in this context is the statistical unit of measurement used to determine how probable it is that a given result is correct. The higher the value, the more likely a particular finding is true, with 5 sigma being the gold standard, representing a 1 in a million chance that a given observation is inaccurate. Though, there's still a chance. You may think I'm splitting hairs here. After all, 1 in a million is as good as true, isn't it? Well, no. A 2011 experiment conducted by CERN purportedly found that a series of nearly massless ghost particles, called neutrinos, had traveled faster than the speed of light. This was, of course, impossible, as the finding violated Einstein's principle of relativity, yet the experiment passed with a 6 sigma confidence, meaning that it had a staggering 1.5 billion chance of being false. And yet it was. 4 later experiments all failed to replicate the original results, and the first experiment was written up as a fluke. Science is very good at explaining what is happening and how it happens, but not really why it's happening. Pass any scientific revelation through a series of why questions, and you'll always get to a point where we just don't know. Take gravity, for instance. When an apple falls from a tree and hits Isaac Newton on his head, we know it's gravity. We can even measure it as 9.8 meters per second. But when it comes to explaining why this happens, almost 350 years later, we're still clueless. Every other physical force in the universe, electromagnetism, strong and weak nuclear force, has a corresponding subatomic particle. Yet we still don't know what the particle responsible for gravity is. Physicists have theorized the existence of something called a graviton that, similar to the Higgs boson, requires massive amounts of energy to detect. In fact, it's predicted that it would take a mass spectrometer the size of Jupiter, operating at 100% capacity, to identify one. But why is a graviton so hard to find? Why is it that physics behaves like this, and is it possible that it could work differently?
You may have heard the theory that it's possible there are multiple universes where you exist in each one but live a different life. and make different decisions, resulting in a totally different outcome in each universe. We know this as the multiverse.
The notion of alternate physics is most commonly associated with the multiverse theory, the idea that there isn't a single universe but an infinite array of different universes. We don't know if this is true, of course, but if it is, then it's possible that among these countless variations, there exists other types of physics. Maybe in another universe, gravity isn't so difficult to measure. Maybe instead, electromagnetism is the rogue force confounding their scientists. But it isn't just other universes that may operate under alternative sets of physical laws. Even our own universe may be subject to alternate forms of physics that we've yet to discover. In 2022, researchers at Columbia University programmed an AI to study video footage of different physical phenomena and then search for the minimal set of variables that described its observations. The footage included things like a pendulum, a lava lamp, and a fireplace. When the AI returned its results, the researchers found that they could identify some of the variables that the artificial intelligence had defined, but not others. The belief is that the AI was applying novel sets of physical laws currently unknown to humans. Unfortunately, since the program can't communicate what it's thinking, the exact variables remain a mystery. However, it does raise an interesting question. If we were to meet an alien species, is it possible that they might use alternate laws of physics? Ted Chiang's novella, Story of Your Life, the inspiration for the 2016 film Arrival, explores this idea. Fair warning, there's spoilers ahead. In the story, humans make first contact with aliens after dozens of spaceships suddenly appear in orbit, but rather than wanting to take over the planet, it seems that the extraterrestrial visitors just want to talk. To get the conversation going, both humans and the aliens work together to slowly decipher one another's language, as well as their respective approaches to physics. It quickly becomes apparent that the scientific and mathematical concepts that are advanced to us, like calculus, are elementary to them. Surprisingly though, the reverse is also true. The aliens deploy strange, seemingly convoluted methods to describe basic principles like velocity. While both methods provide accurate results, each is highly specific to the species that developed them. Eventually, it's explained that the aliens don't perceive our universe as causal. Instead, they witness all events as happening simultaneously. This accounts for their weird set of physics. Chiang's Story of Your Life raises interesting questions surrounding concepts like time, perception, free will, and subjectivity, forcing its readers to wonder if there's such a thing as objective reality. How do we know that the reality we experience is independent of our own consciousness? This problem has plagued philosophers since antiquity. Plato, in particular, is known for having proposed the idea of the realm of forms, a non-physical, immaterial plane from which the physical world manifests. Science actually functions on a similar principle, assuming that there is an objective reality that exists beyond our senses, which can be observed and measured. Despite our best efforts, though, no one has ever confirmed the existence of an objective reality. In fact, given that everything we know has to come first to us through our senses and therefore our own subjective perception, it's impossible to prove an objective reality. We'll just never know. In his book, The Spell of the Sensuous, philosopher David Abram argues that the very idea of an objective reality isn't representative of the universe we live in. In actuality, Abram says we exist in the realm of inner subjectivity, a term he borrows from the German philosopher Edmund Husserl. This form of reality, rather than being a separate and isolated phenomenon, is created by the collective experience of all its participants. The universe doesn't exist as an object of our subjective perceptions. Instead, it arises out of our very interaction with it. If this idea sounds a little out there, consider quantum mechanics, where our mere observations literally affect the state of matter. Just by measuring a photon of light, we're able to change it from a wave to a particle.
But experiments in the last 200 years or so have proven that what light appears to be and what light is are actually two different things.
So maybe there's no such thing as objective reality. Maybe all that exists is our collective intersubjective experience. There's simply no way of knowing. Plunging into the depths of uncertainty is never pleasant. That's why humans came up with reason and science in the first place. We want to feel as though we know things. It gives us a sense of control in an otherwise chaotic, unpredictable, and sometimes dangerous universe. For the majority of my life, I was agnostic about most things. If there wasn't what I deemed to be rational, scientific proof to support an idea, I just didn't believe it. But the more I learn, the more I realize how limited my own experience is, and just how much we as a species don't know. Ordinary matter accounts for just 5% of the entire universe. The rest of it, 95% of everything that exists, is a complete and total mystery. We just don't know. It seems naive, if not outright arrogant, to close myself off to new ideas just because they don't fit within my current understanding of how things work. Tomorrow, the Earth could shift, life as we know it could completely change, and everything that science has taught us could turn out to just be a fluke. But rather than meeting this dilemma with fear or outright rejection of scientific principles, we should take it as an opportunity to learn, embracing uncertainty as a means of transforming our perception. To me, this seems like the only rational path forward. Because as it turns out, everything we don't know is, well, everything.